Okay, so this is my video to explain homework 3, which is implementing heap delete and heap print. Let's start with heap print. So this is basically, I did the same way as heap remove. It's just identifying the index is a little bit different. So instead of this function, instead of taking an index, it takes in the pointer, which points towards the person itself. Like in this case, it's the person. Um, Yeah, so obviously first, if the heap size is 0 and there's nothing in the list, return 0. Set up to find the index, and then here, instead of comparing it with the native compare function, here we're using the direct one that we receive when allocating. And so you can see here that I'm comparing each node I here one by one until we find it that is same as E, which is the argument that we receive. Then we found the index. If the index is 0, actually that means nothing changed. That means the element doesn't exist in the heap. And then we copy the last element onto that spot. That's how we are gonna remove that that node completely gone. Reduce the h size by 1, and this is basically the same thing as heap remove. Just instead of starting from the top, we start from that node that we deleted. So that's for heap delete. Okay, let's get to heap print. Before we start talking about the function, I want to pull this up first. This is what I did to formulate the numbers. So what I did was I just drew the pyramids out. I just drew the the printing out, the potential printing, how it's gonna look like, and I literally just pulled out these 3 variables. These are the only 3 variables that I'm interested in. So the first one is the first indentation, because you could tell that to print the first element in that level, the indentation is different compared to the other side. So you could see here that there's 3 indentations because of the first element, and there's 7 indentation before the second element. So that's the first thing we look out for, and then we print. The next variable we're looking for is, after printing the first one, how many elements left is it to be printed on that specific level or the specific line. So let's say in this case, as it's printed 1, there's 3 elements left, right? And then we also check after that first element, what is the indentation for the other element. So you could tell here that the first element here is 1, but the other elements, the indentation is 3. So we need to look at that numbers too. And then now, I just pulled out the numbers. I just literally counted them. I didn't even calculate anything. I just counted, put the numbers in, and then these are the numbers. And you could tell that, oh, there's a pattern here. Coincidentally, I also have this list, which is the powers of 2, which is 1, 2, 4, 8, 16, 32. And I just decrease each and every one of them by 1. And you get this pattern. So all I did was just find formulas to access these numbers depending on their level. Yeah, so let's get to the code. So the first thing that I did here is obviously check the size. If it's 0, return. And then we need to find the height, because you need to calculate what our calculations need the height, right? You could see here that, let's say here there's 1, 2, 3, 4, 5, 6, 7 elements. We know that it's still level 3, but the moment it hits 8, we know that it goes through it becomes level 4. The height is 4. So that's exactly what I'm doing, is marking these thresholds. The moment it goes past a certain number, that's the height that we want. And then we generate these numbers based on the height, because we don't have to recalculate them every time. We just have to pull them from the array. And then we start from index 1, which is our first element. This is our height. So for each height, it's gonna print those things respectively. So first it prints the indentation, which is let's say this one. It prints how many tabs to do, like how many indentations to do. Prints the element, and then finds how many elements left to print in that line with this formula here. And then it prints the indentation for everything else other than the first element in that line, and then it prints the element. Now, one thing to check is, before printing the element, we need to check if that index is within still the heap size. If it's not, if it's already outside the heap size, that means the value actually doesn't exist. or at least it's not supposed to work that way, and it's gonna have a segmentation error. So yes, make sure to check this first before printing. And this is the results. So I'm simulating a deletion here as well, all the way until the last element.